Okay, now we need to tell it where do we send these mappings to. So who's the map server and who's the map resolver? The map server is the one that we register with. The map resolver is the one that we ask, what's the mapping for the other guys? In our particular case, it's both at the same time. So we're going to say that we are an ingress tunnel router. We are also an egress tunnel router. When we go to do a mapping, when we are sending traffic out to the core, so it's ingressing to the core, who do we ask where the addresses are located? We're going to ask the map resolver. Map resolver's address is router 8. When we go to tell the map server what our addresses are, okay, as the egress tunnel router, the map server is the same box, 8888. So again, they technically can be different values, but in most cases it's going to be the same router that's doing both the role of the map server and the map resolver at the same time. Okay, this here is where we're going to specify the authentication key. So authentication key, I said on the other side, let's look at router 8, which is R5 PASS. Okay, that's it. So if we show run section LISP, really not a ton that's involved with it. We're basically just saying who do we register with and then what are we going to register. Now if we look at router 8 who was doing the debugs, we should see that it got a registration message that it said we received a map register. So map register, this is router 5 telling us that it has reachability to this specific prefix. And also, the way that you can reach that prefix is from the IP address 10.1.5.5. The priority was 100, the weighting was 50. Okay, now we know this inside of our mapping database. So on the map server, if we look at the show LISP site, this tells us who did a registration and what prefix did they specifically register. This is basically the equivalent of the DNS database. It's the mapping between the inside address, which is the EID, and then where we're going to forward the traffic to, which is the routing locator. Now, what we're going to use this information for later is that if another LISP router says, hey, how do I get to the prefix 6666/32, it says, hey, tunnel your traffic to 10.1.5.5. And John, like you said there, yeah, it's kind of like NHRP on steroids. So in the case of DMVPN, you have your DMVPN hubs that have this database of mapping the inside tunnel address to the overlay, or the overlay to the underlay address, basically the tunnel address to the NBMA. It's basically the same exact thing here. The difference, though, is that we're not tunneling it inside GRE, we're tunneling it in UDP, and it's automatically a full mesh of tunnels because we're not running routing on top of it. So in DMVPN, you need to run some sort of routing inside of it, like EHRP, BGP, whatever. But in this case, we're using the underlay routing, like just a default route, in order to send the traffic towards the core. And then we're assuming that the core already has reachability to the infrastructure, which would be this routing locator. Okay, so again, the whole key magic about this is that unless we can ping the routing locator, we're not going to be able to reach the inside destinations. Okay, so we're going to do the same thing on the other side. If we look at on router 5 and look at the show run section LISP, we could basically take the same exact thing that we did on 5. We're going to put it over on router 3, but we're going to change what the address is that we're registering. Okay, so we're going to say that we have 7777, and then we are registering the address that is going to be 10233. Okay, specifically this is this guy here. So on router 3, this is, we're registering those addresses. Okay, if we look at the map resolver or the map server and look at the show LISP site, we should see in a second that we get a registration from router 3 that's going to tell us about that particular source. Okay, so let's look at router 3 and show run section LISP. And what's wrong here is that password. Okay, password needs to be unique between them. So on router 8, if we look at the show run section LISP, this is how we're keeping the sites different, because notice what the map server is not, it doesn't know in advance, it doesn't know what the routing locators are. So you need to make sure that these passwords are unique between them, otherwise you won't actually be able to do the registration. Okay, so site router 3, I forgot a password there. Let's say authentication key is R3PASS. So router 3 is going to say, use that password. Okay, on the map server now, if we look at the show LISP site, we see now router 3 registered this particular endpoint identifier. Okay, now we're ready to actually send traffic in the data plane. This again is assuming that the devices on the inside, like your servers, are pointing their default gateway at someone that has routing reachability to the rest of the network. So like if we look at router 6, and router 6 is going to say, how do I get to router 7? We don't have a route to that. But we do have a default route. Okay, so we have a CEF entry. Same should be true for router 7 on the way back. If we show IPCEF 46666, it says use the default. The difference is now going to be when it gets to the edge, which the edge being router 5 and router 3, these are the ingress and egress tunnel routers. So from router 3's point of view, when we look at the CEF table, it does not have an entry for that particular destination. This is what triggers the mapping request to go to the map resolver. It's basically saying, I'm running LISP globally. If I don't have a match in the regular routing table, ask LISP, do you know a route? So the same is going to be true from router 5's point of view. If from 5, if we look at the show IPCEF 47777/32, it says we don't have that particular prefix. We do have a default route though. So this is going to be part of the reason that we're triggering the LISP process and then asking the map resolver. So basically, if you either have a default route or you have no route, then you ask LISP. If you have a more specific route, you're going to do just your normal native IP forwarding. Okay, so next let's look at what's going on in the data plane before we actually send the traffic. So let's do a capture here. And we'll leave just everything running. Okay, we'll need to sort through some of this in a minute here. So let's then do a ping from 6 to 7. So we're going to ping 7777. Source is 6666. We should see that the first couple packets get lost. This is while we're in the process of doing the resolution. And then once the resolution is complete, then we have IP reachability. Okay, so let's look at what happens specifically in the data plane. Okay, what we should have seen, and let me sort through, let's get rid of some of the stuff that we don't need. Like, let's get rid of, let's say, it's not ISIS, and it's not EDGRP, and it's not CDP. Okay, most of the stuff left over should be the pings and then the actual LISP traffic. Okay, so we had a LISP request that first started from router 3. Okay, router 3 is asking the mapping server, how do I get to a particular destination? Okay, this is going to be a map request. So the map request is going from 3 over to 8, and then it's basically saying, how do I get to the, or actually this is the registration. Okay, in the registration for this, it's basically telling the map server that if somebody wants to get to 7's loopback, they should use this as the endpoint to try to get there. Okay, specifically the encapsulation for the control plane here is UDP port 4341. So it's an IP in UDP tunnel. Then LISP is in the payload. Okay, we should see shortly after this then that router 3 is going to ask, how do we get to the other side, which is basically the encapsulated map request and the map replies. So this is now router 5 telling router 7, hey, if you want to get to me, you need to use this particular routing locator. So you're trying to get to 6666, and the request came from 7777. The end result is that you should use 10155 to get there, but I need to know, how do I get back to 7? So basically, the map server map resolver is kind of like a middle man in the middle there, that we ask the map resolver. Map resolver says, yes, I know the mapping. You need to ask router 5. Router 5 is the one that actually has the mapping. So it gets forwarded to 5. 5 says, okay, the mapping came, or the request came from router 3. Ask router 3, how do I get back to you? Because we need this bidirectional resolution. The end result of this is that if we look at 3 and 5, and we look at the show IP LISP map cache, we now know that if we want to get to 6666, we go to 10155. And likewise, in the other direction on router 5, if we look at the show IP LISP map cache, it says if you want to go to 7777, you really need to tunnel the traffic towards router 3. Okay, so we now look at this in the data plane and look at the actual pings. It's basically just whatever the original traffic was, so a ping from 6 to 7, but it is going to be encapsulated in the next header. It's going to be encapsulated inside of Lisp. So it's the original packet, then we put the Lisp UDP header on it, and then put a new IP header on it. So what this means from an infrastructure routing point of view is that we don't care, like from router, let's say router 2's point of view, who's in the middle of the network. Router 2 does not need to know a route to the source or the destination. Same exact logic in MPLS layer 3 VPN. That in L3 VPN, the only thing we care about is the label between the ingress PE and the egress PE. In our particular case here with Lisp, we only care about what is the ingress routing locator in the egress routing locator, because we're basically tunneling traffic from here to here. Now, what the beauty of the protocol is, though, is that the control plane is really lightweight. We don't have to enable Lisp on all of the boxes in the middle. The only thing that they need is IP reachability to each other. So as a customer deploying this, you technically don't even need to get the provider involved at all. You could basically say that one of my edge routers is going to be the map server and the map resolver, and then all of my remote sites would just do the resolution requests to them, and then it would transparently tunnel all of the traffic over the provider in the middle. And since it's a UDP tunnel, it also means it's going to be friendly with network address translation, it's going to be friendly with active firewalls as it goes through, and it's also going to be able to be load balanced from multiple links in the core, because they're going to be hashing based on the flow data, which is based on the UDP port numbers. Okay, so this is going to be the next main use case is, what if we have multiple interfaces? Okay, so right now all of the traffic is going directly between router 5's interface here and router 3's interface in the middle. Okay, let's go ahead and recap the config here real quick. So we look at the show run pipe section Lisp. So this guy is the one that's doing the mapping database. It's saying, I'm expecting somebody to register 7777 and start something that starts with 10.3/16. Okay, anything after that, I'm going to allow it. So if it's 10.3.10/31, that's fine. Okay, but as long as they authenticate with that particular password. Okay, then likewise, I have another site that is registering these particular addresses. But notice what we do not have here. We don't know where the registration is coming from. We don't yet know the routing locator in advance. And that's why it's called a separation protocol. That we're making a level of indirection between what is the service being the endpoint ID like your web server, and then where is that service located, which is the router's interface. So from a virtual machine mobility point of view, basically what you would do is, let's say that these are two different data centers, that router 5 is data center 1, and then this is data center 2, and this is our data center interconnect between them, basically like it's a layer 2 circuit end to end. And your virtual machine is sending traffic this direction. Router 5 is going to announce it with this particular routing locator. But when the virtual machine moves, let's say we do a vMotion and now it's over here, router 4 is going to update this and tell the map server, hey, that virtual machine moved, and now it's located at this new spot. So anybody who wants to get to router 6 is now going to go in this direction as opposed to going over to router 5. Okay, but for our use case, it would either be for transparent overlay tunneling, so the same thing as like an L2TPv3, but in our case we're doing a layer 2 tunnel or layer 3 tunnel as opposed to a layer 2 tunnel. Could be the same use case as like a GRE tunnel or a DMVPN, where the devices in the middle don't need to participate in our routing, we're just hopping the traffic over them. Okay, the other two examples I'm going to show here are for tunneling IPv6 and IPv4, and then for load balancing the ingress traffic when we have multiple routing locators that are assigned to the same endpoint IDs. Okay, so map server configuration, pretty straightforward. Then likewise on the ingress and egress tunnel routers, we're saying this is the guy we're going to ask. When we register with them, this is the password that we need to use, and this is specifically what we're registering. We're saying this endpoint ID is located on that router's interface, the routing locator. Okay, again, the priority and wait, this is only going to matter if we have multiple mappings that are going to the same, or excuse me, multiple routing locators that are mapping to the same endpoint ID. Then from a verification point of view at the map server, we looked at the show LISP site. This shows us the registrations. If we were to go to router 7 and let's say we just do a ping to 6666, we should see in a minute here, once the registration goes through, that, and actually I need to make sure that, let's see, do we have a route to this? Show IPsef 6666 is via 10373. And actually on router 3 I didn't set that as a database mapping is what the issue is. Okay, so let me add that as well. Router LISP, let's say show IP route connected. Our database mapping is going to be for that prefix, or no, this one here. Okay, that's the internal route. And it's mapping to the interface address, which is this guy. The priority is, we'll say 100, and then the weighting is 50. Okay, but again, in this case, since there's only one routing locator, these values don't matter. You just have to assign them, but it doesn't really matter what it is. Okay, now on router 8, if we look at the show LISP site, router 3 now registered this. It said it registered a more specific prefix, the /24, but it's part of that aggregate, so that's allowed. So now when router 7 goes to ping to 6, we're going to do the resolution to the other side. Now router 5 is going to know when we show IP LISP map cache, it knows if I want to reach this guy, go to router 3. Okay, so there was a question here. When we go to create a flow, you don't have to ask the map resolver every single time. You first check your local cache, and as long as the cache information is there, then you go ahead and do the encapsulation. There are, of course, timer values and a bunch of customization you can do with this stuff. The potential problem would be like what happens if one of my links goes down and I don't tell the map server that that was a problem. Then someone is going to be resolving traffic to an interface that doesn't exist. So there's some other polling mechanisms that are built in there that you can say, hey, the link went down, tell the map server about that to withdraw the routing locator. But otherwise, I think this is like a minute by default that it continues to poll it. And you'll see this if you look on the map server and you debug LISP control plane all. You'll see about every minute or so, router 3 and router 5 are basically pinging it saying, hey, I still have this registration for that particular prefix going to this particular endpoint ID. Or excuse me, going to that particular routing locator. So if we look at the show LISP site, which is that, this is saying router 3 is saying, hey, I still have 7777/32, and this is the routing locator that you can reach it via. So if we say show LISP site detail, this will show you all of that stuff that's in the payload. Okay, so what's the actual prefix that people would want to reach? How do we reach it, which is via the locator? And then what's the priority and what is the weighting? Okay, scope is going to be what's the what's the inside protocol. In this case, is IPv4 as opposed to IPv6. There's a question, router 8 wasn't allowed already 10.3. Yes, it was, but the problem is you have to match it on both sides. So the reason that router 7's ping did not work was that on router 3, when we show run section Lisp, I didn't tell it to register this address. Okay, once I told it to register the address, then the mapping server says, check the password of the, or more specifically, check the hash value of the packet coming in. If it matches that hash, we know it's related to this site. Okay, then specifically that site is allowed to register these particular prefixes, these endpoint IDs. And in our case, we were registering 10.370/24, which is a subnet of that particular aggregate, so we're allowed to accept the more specific prefixes.